This is section 5.2. We're now going to be dealing with systems of linear equations in 3 variables. I mentioned this in section 5.1. The number of variables you have needs to match the number of equations you have. So since we have x, y, and z, we now have 3 equations to deal with. Now we've talked about in 5.1 how these systems had a graphic interpretation as to where 2 lines intersect. So our answer was an ordered pair where those 2 lines intersected. We still have the same thing happening here. We have 3 equations. It's just now that we're not graphing, quote unquote, in 2 dimensions anymore. We're now graphing in 3-dimensional space. Now, I'm not going to make you do that, but these are 3-dimensional objects, and if we do have a solution, they do intersect in one point in 3-dimensional space. And we're going to write our answers as ordered triples. And ordered triples are always x, y, z. Okay, now these problems are long, but they're not particularly difficult. I don't think you're going to have any trouble following every step here, okay? But there are a lot of steps. I'm going to be showing you one way through these problems. This is not the only way, but this particular process I'm going to show you will keep you from accidentally undoing things that you've done before or working in circles, which is also very easy to do. The other thing you want to be careful about is you really want to double check every single step. Check your arithmetic at every line. Make sure that you have recopied things correctly every single time. One tiny mistake on these can blow up on you. It can mess up everything else. Okay, so how am I going to work these? The first thing I'm going to do is I'm going to label these 3 equations 1, 2, and 3. And that is so that I can refer to the equation without having to rewrite the whole thing. So I'll be talking about, this equation, and I'll just call it 1. I won't have to write it all down. It saves room, helps you avoid copying errors, those types of things. Okay, now I'm going to be solving all of these using the addition/elimination method. Technically, you can use substitution on here, but they get really ugly if you do that. Okay, so the first thing I'm going to do is I'm going to take equations 1 and 2, and I'm going to group these together, and I'm going to choose to eliminate a variable. It does not matter which one. So if I pair up 1 and 2, it looks to me like z is going to be pretty easy to get rid of. Now, this has a 2, this has a -2, this has a -1. If I multiply this second equation by a 2, then they both will have -2's. And I need to have opposite signs, right? So I have a -2 here, I need a +2 here. So I'm going to multiply the entire second equation by a -2. So recopy your first one, since I didn't multiply it by anything. And then multiplying everything here, including the 5. That people always forget that last number. So multiply everything through here, and you get -6x plus 6y plus 2z is equal to -10. Now we're going to add these together. Our z's cancel out, and we had designed it that way, so it's a good thing. And now combine like terms here, and you have -4x plus 7y is equal to -11. What we've done here is we've taken something that had 3 variables, and we've simplified it down to 2 variables. Now we're going to need this equation, but we are not ready to use it yet. We have to build some more pieces. So I'm going to call this equation number 4, and we will refer to it later. Okay, so now I've paired up 1 and 2. Now I'm going to pair up 2 and 3. And we're going to eliminate a variable. The thing is here, we need to eliminate the same variable. Okay, if you don't eliminate z again, although technically, algebraically, you haven't made a mistake, you're starting to work in circles and it's not going to do you any good. Okay, and so also, when you are choosing which variable to eliminate with 1 and 2, you may want to look at 2 and 3 also to make sure you pick something that's decent for both pairings. Where, for example, z might be really great. Well, let me look at this. For this, y is pretty easy. But right here, y is less easy. So I went with z, which is fairly easy here and fairly easy here. Okay, but it would work with any of these. It's just whatever variable you get rid of here, you need to get rid of again. So if I'm looking at z with 2 and 3, they already have opposite signs, and I can get a negative 3 here by multiplying all of equation 2 by a 3. So 3 times all of equation 2. That will give me 9x minus 9y minus 3z is equal to 15. And we're not changing 3, so recopying, be super careful that you get all your signs right and everything else. Okay. So the z's canceled out as we wanted, and we add these together to get 10x minus 11y, and that would be equal to 21. We also need this equation. I'm going to call it equation number 5. So it will help you if you understand why we've just done this. One of the things we do in math a whole lot is we take a difficult problem and we simplify it to a type of problem we already know how to solve. When we got rid of z here and z again, we ended up with 2 equations that have the same 2 variables. It doesn't matter what they are, as long as I have an x here and a y here, or I could have had x and z, just so long as you have the same 2 variables. That was the whole purpose of doing these 2 steps. We know how to solve these. This is exactly what we did in 5.1. I'm going to now pair up 4 and 5, and this is going to be my new system. Now I need to get rid of a variable. Neither of these is particularly easy, but y looks worse to me than x. So if my common denominator, if I'm looking for a common denominator between a 4 and a 10, I'm going to try to make those into 20s. Okay? So I'm going to get rid of x, and I'm going to turn these into 20s. Now they already have opposite signs. So if I multiply equation 4 by a 5, I will have a negative 20. And if I multiply equation 5 by a 2, I will have a positive 20. Okay, so let's multiply through here. We get negative 20x plus 35y is equal to negative 55. Now multiply a 2 through here. 20x minus 22y is equal to 42. Now add these together. Your x's cancel out, and we get 13y is equal to negative 13. So this we can solve, and we can find y. Divide both sides by a 13. And we know that your y value is equal to negative 1. So I have one part of my answer. I need all 3 parts. I need to know x, y, and z. Now what we did here when we had a problem in 5.1, we found one variable and then we plugged it back in to find the other. Well, that's exactly what we're going to do here. You're going to plug in this value, and I use this double arrow to indicate that I'm plugging in. I'm going to take in this value I know, and I want to plug it in someplace where I can find another variable immediately. Now it is legal to plug in up here. But if I plug in y here, I'll still have an x and a z that I don't know. It's legal, but it's not really getting you anywhere. So I want to plug into either 4 or to 5 because that will give me my x value very quickly. So pick whichever one you think looks easier. I'm choosing 4. But I'll make a note here that at this step, I could have plugged into 5. So when I plug in -1 for y, I get -4x. That's going to be -7 is equal to -11. So add 7 to both sides. -4x is equal to -4. Dividing both sides by a -4, you get that your x value must equal 1. Okay, so now I have 2 parts. I need all 3. I need to go find z. So I'm going to plug in both of these values, someplace where I can find z. The only place I have z's, because z was the first thing I got rid of, the only place I have those is up here. So now I have this value, I have this value, and I'm going to plug in to either 1, 2, or 3. And since I'm trying to find z, it looks easiest to solve for z right here, so I'm going to plug into 2. But again, at this step, I could have plugged into 1 or also 3. Just someplace where you can still get a z. So right here, I have 3 times 1 minus 3 times -1 minus z is equal to 5. So that is 3 plus 3 minus z is equal to 5. 6 minus z is 5. Subtract 6, -z is equal to -1. So our z value is 1. The answer to this system is the ordered triple x, y, z. 1, -1, 1. Now I do strongly suggest that you take this and you plug it in up here and check. It has to work for all 3 of these. I plug in 1 for x, -1 for y, 1 for z, and they all should check out. Now, I think you can see what I meant. These are long problems, but I don't think you'll have any trouble understanding every step. Okay? You just need to slow yourself down, double check everything as you go along. Otherwise, you are going to be incredibly frustrated when you're doing this homework.